Let me record this. All right. So my little memory tool for remembering some stuff, I'm going to write in the bottom, is Bobo Botan eats DC. So here, this is for remembering horizontal asymptotes, because vertical asymptotes are always what makes the denominator 0. So this is to help you remember how to horizontal asymptote is. So Bobo stands for bigger on bottom, 0. Botan stands for bigger top, none. And eats DC stands for exponents are the same, divide coefficients. So Bobo Botan eats DC. So the two that you have on your quiz today are the eats DC, exponents are the same, divide coefficients, and the other one you're going to have is Bobo, bigger on bottom, 0. Now realize what that means is that fraction part is 0. So like this, you're looking at this. That's bigger on the bottom, so that's 0. 0 plus 1 is 1. So it's not 0, it's 0 plus whatever you have, if you have. You sometimes don't have anything after it, but if you have something after it, that part's 0, and then you would add or subtract. So Bobo Botan eats DC. Bigger on bottom, 0. Bigger on top, none. Exponents are the same, divide coefficients. And I'm going to keep saying this all day. All right. So let's take a look. And now, if you didn't finish copying, I'm going to zoom back into that bottom part when we do the second problem. So don't worry. Oh, I can't zoom in once I start recording. That's a pain. Okay. So the stuff we're doing today, X-intercepts, we talked about this the other day. So X-intercepts for a fraction are what make the numerator 0. So as long as my numerator is 0, 0 over 10 equals 0. 0 over 100 equals 0. So for a fraction, as long as the numerator is 0, the fraction is 0. And then today we're going to talk about wholes. So we're going to be factoring and seeing if anything cancels. And when something cancels that has a variable, it creates a whole. So we'll talk about that a little more after. And then this is the same. Vertical asymptotes are always what makes the denominator 0. And the horizontal asymptotes, that's the Bobo Botan eats DC. So this up here in your notes is m is the degree of the numerator and n is the degree of the denominator. So the two that we've done, the two that were on your warm-up and the two that are going to be on your quiz are the first two. So number 1, if the degree of the numerator is less than the degree of the denominator, then 0 is the horizontal asymptote. That's this. That's Bobo, bigger on top, 0. My degree here is 0. My degree here is 1. This part is 0, and then plus 1 is how I got 1. This is the second kind that's on your quiz. If they're the same, then divide coefficients. So same degree, they're both 1. The horizontal asymptote is 2 divided by 1. We divide the coefficients. And then the last kind we're going to do today is if the degree of the top of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. So we'll have that today too. All right, so let's look at the first one. The first one is one that could be on your quiz today. So this one, which one is it? Bobo, Botan, or eats DC? Is it bigger on top or bigger on bottom? My exponent here, if there's no variable, is 0. And my exponent here is 1. Which is bigger, 0 or 1? So it's bigger on the bottom. So this is Bobo. Bigger on bottom, 0. And there is actually nothing after it. I mean, if it makes you feel better, we could do this, because that's what we've been looking at, what's after it. So we could write a plus 0. So that's my horizontal asymptote. Y equals 0. All right, my vertical asymptote. What makes my denominator 0? 3. So I've got x equals 3. So let's put those on. So again, 1, 2, 3. Make sure you draw the vertical one vertically and the horizontal one horizontally. All right, if my zeros are what makes the numerator 0, what if my numerator is 4? Can my numerator ever be 0 if it's 4? If I set 4 equal to 0, can I solve for anything? So what does that mean for my 0? Am I going to have a 0? No. Right? There's going to be no 0. So there is none. It's not going to cross the x-axis anywhere. That means it's not going to cross the horizontal asymptote because my horizontal asymptote is on the x-axis. All right, let's get some points in graph before we do domain and range. So we've got y equals negative alpha y equals enter 4 over x minus 3. And we want the 2 points above and 2 points below. I'm going to use ones that are not fractions. I'm going to take 1, 2, that's a positive 1, 2, 4. So 3 is my error. This is where it's undefined because this is my vertical asymptote. And then I have 4, negative 4, and 5, negative 2. So for graphing, I've got 1, 1, 2, 2, 1, 2, 3, 4, 1, 2, 3, 4, negative 4, 1, 2, 3, 4, and 5, negative 2. And whatever you graph, if you'd rather look at the picture on your calculator before you draw your curve so you know what it looks like, do that. Push graph and then do your curve. Or your curves. So here's that one. And here's that one. And it matches my calculator picture. All right, so now my domain. What can't my x be? Yeah, it can't be my vertical asymptote. So my domain starts at negative infinity, it stops, and we use parentheses because we're not including 3, and then we start up again at 3, and it goes to infinity. How about my range? What value of y am I not using? 0. I'm not using the horizontal asymptote. So again, I start at negative infinity, I stop at 0, I start up again at 0, and go to infinity. When you're writing your domain and range, you do it from small to big. So left to right for domain and down to up for range. It should always be the smallest number on the left and then the big number. Small number and then big number. Sometimes I see people write it the other way. All right, any questions on that one? That is exactly like one that would be on your quiz today. Other than the one on your quiz has something after here. All right, let's look at the next one. Here's another one that could be on your quiz today. Which one is this? Bobo, Botan, or Eats DC? So my degree here is 2. My degree here is 2. Eats DC. This is an Eats DC. Exponents are the same. Divide coefficient. So my coefficient here is 3. My coefficient's 1. What's my horizontal asymptote going to be? 3. Okay, and we said vertical asymptote is always what makes what 0. Okay, so on this one, guess what? We got a factor. If I set this equal to 0, the way I actually solve quadratics is by factoring. So this one is difference of squares, x plus 2, x minus 2. Which means how many vertical asymptotes am I going to have on this one? 2. So I have 2 different values that are going to make my denominator 0. One is negative 2 and one is positive 2. So I have 2 vertical asymptotes. So here's the one at negative 2. Here's the one at positive 2. So actually you don't have something like this on your quiz because we don't have 2 vertical asymptotes on your quiz today. 1, 2, 3. And here's my horizontal asymptote. Okay, so let's get some points. So y equals alpha y equals enter 3x squared over x squared minus 4. All right. So again, we want 2 above and 2 below. You can put more than 2, but at least 2 above and at least 2 below. So 0, 0, 1, negative 1, 2, this is my vertical asymptote. This is where it's undefined, right? On your calculator, you get, it says error. And then I've got, let's see if I can get some integers here. Maybe not. All right. So I've got 3 and 27 over 5. 4, 4. Now, what's the problem with the table I have so far? I said we need at least 2 above and 2 below. But what's my problem? I have 2 above and 2 below this vertical asymptote, but how many vertical asymptotes do I have?
2.
2. So I need some more points. This is not enough points for this one. I have 2 vertical asymptotes. I've got to go up to the other vertical asymptote. So I've got to add some points. I've got 1, negative 1, 0. I'm going to make them go above. Negative 1, negative 1, and then I got to negative 2, which was another error. This is my other vertical asymptote. So I need to make sure I have some above that as well. So negative 3, 27 over 5, negative 4, 4. So the point is, if you have more than one vertical asymptote, you're going to need more points. You're going to need a couple above each and a couple below each. So we've got, for my graph, 1, 2, 3, 4, 1, 2, 3, 4, and then 27 over 5 is 5.4. So when I do this one, 1, 2, 3, I want to go 1, 2, 3, 4, 5, a little bit past 5, not quite in the middle. And then I've got my vertical asymptote, then I'm here at negative 1, 0, 0, 1, negative 1, and then I'm here at 1, 2, 3, and again this is 5.4, so 1, 2, 3, 4, 5, a little bit above, and 1, 2, 3, 4, 1, 2, 3, 4. So on something like this, because we haven't seen something like this before, I would definitely look at the graph before you try graphing it. So hit the graph button so you know what it is it's going to look like. Okay, so these two up here make sense. This is what I've been doing. I've been connecting these 2 dots with curves that get closer and closer to the asymptotes. But down here, this is a little different. So it really helps to look at your calculator, or else you may not know what you're drawing here. So this one is, it's getting closer and closer, goes down, closer and closer. How about my zeros? If I set my numerator to 0, what's my 0 for this one? What's the only way to get 0 if I'm multiplying? You've got to multiply by 0. So that means x is 0. Then we have that graph right there. That's my 0. All right, my domain's going to be a little more complicated than the one we just did. Because if you look, as I go from left to right, I'm going. I stop here at this vertical asymptote. Then I start up again, and I go, and I stop at this vertical asymptote. Then I start up again, and I go to infinity. So it's got 3 parts. So I start at negative infinity. I stop at the first vertical asymptote. Then I start up at the vertical asymptote until I get to the next vertical asymptote, and I stop. And then I start up at that vertical asymptote, and I go to infinity. And that's why it helps to have the picture before you start doing domain and range. Because as you go from left to right, you can see, oh, I stopped. Okay, I started, oops, I stopped. Started, keep going. All right, my range is also a little bit different. If you go from bottom to top, I'm going. Do I make it all the way to the horizontal asymptote for this one? No, I stop right here. And then I start up again here and go to infinity. So I go from negative infinity and I stop at 0. Am I including 0? Yeah, it's my 0. So it's going to have a bracket, not parentheses. And then I start up again, not including the horizontal asymptote, to infinity. So my range is also different on this one. Any questions on that one? Okay. So let's look at the third one. Right away I see that we're going to need to factor. So there is more factoring, always factoring in Algebra 2. The top I can factor because it has what? It's not difference of squares because x is not a perfect square. But I can factor out an x, a GCF. So I've got x minus 4. On the bottom I also have a GCF. So I have a GCF of 4, which gives me x squared plus x minus 6. And then I can keep going, because now I'm looking for two numbers that multiply to be negative 6 and add up to be 1. And that would be positive 3 and negative 2. And then I look and make sure there's nothing I can cancel. There's nothing the same on the top and bottom, and there's not on this one. So how many vertical asymptotes is this one going to have?
3.
I hear 3 and I hear 2. Who thinks 3? Who thinks 2? So it depends on, there are 3 things here, but if I'm solving, they need to have x's. Right? If I set 4 equal to 0, I can't solve for anything. But I can solve x plus 3 equals 0, x minus 2 equals 0. So there's going to be 2 on this one.
What about x minus 4?
That's on the top. So remember, vertical asymptotes is what makes the denominator 0.
Right.
So there's my 2 vertical asymptotes. All right, which one is this? Bobo, Botan, or Eats DC? Look at your highest. Yep, Eats DC. This one is Eats DC. Exponents are the same. Divide coefficients. All right, if I divide coefficients, what's my horizontal asymptote? 1/4. Right, this is a 1, that's a 4, 1/4. All right, how about my zeros? I'm setting my numerator equal to 0 and solving. How many zeros does this? So I've got 2 different things, right? I set the first part equal to 0 and the second part equal to 0. This is different from this because there's a variable here. I can't set 4 equal to 0. I can set x equal to 0. So this is already solved, and this one, if I solve, gives me x equals 4. So there are 2 zeros because there's 2 factors with variables. This factor does not have a variable. All right, so let's graph what we have. We have a vertical asymptote at 1, 2, vertical at negative 3, and at positive 2. The horizontal, do your best to put it at 1/4. You're kind of estimating as best you can.